My topic for this chapter is all about intelligence and working memory. Working memory, in particular, is strongly correlated with intelligence in children and adults. When people perform better on a working memory task, they also tend to perform better on an intelligence task. More intelligent adults are thus more efficient problem solvers because they have summoned up less energy. Recent work suggests that a critical component of intelligence may be working memory. Indeed, some investigators have argued that intelligence may be little more than working memory. Kylenel and Crystal, 1990. In one study, participants read their set of passages, and after they have read the passages, tried to remember the last word of each passage, by Daneman and Carpenter, 1983. There are indications that a measure of working memory can provide almost perfect predictions of scores on tests of general ability by Column et al. 2004. See also Kane, Hamburg, and Conway, 2005. Other researchers have demonstrated a significant but smaller relationship between working memory and general intelligence. Ackerman, Beer, and Boyle, 2005. Thus, it appears that the ability to store and manipulate information in working memory may be an important aspect of intelligence. It is probably not all there is no intelligence, however. So, next topic is about multiple memory system. The working memory model is consistent with the notion that multiple systems may be involved in the storage and retrieval of information. Based on such findings, Indel Tolving, 1972, proposed a distinction between two kinds of explicit memory. First is the semantic. Semantic memory stores general world knowledge. It is our memory for facts that are not unique to us and that are not recalled in a particular temporal context. The second one is the episodic memory. Stores personally experienced events and episodes. And also, according to Tolving, we use episodic memory when we learn lists of words or when we need to recall something that occurred to us at a particular time or in a particular context. Also, Tolving says 1983 to 1989 provide support for the distinction between semantic and episodic memory. It is based on both cognitive research and neurological investigation. So as you can see, an example of semantic memory is apples. Object knowledge learned over many interactions. In episodic memory also, memory for specific events that you have experienced like birthdays, anniversaries, like that. Okay, next. Some neurological evidence suggests that these two types of memory are separate. However, through neurological methods, investigators found dissociations, which means that separate and distinct areas seems to be involved in semantic versus episodic memory retrieval. Prince, Chu, Cura, and Cabeza, 2007. So in contrast, in this page, there is more activation in the right than in the left prefrontal hemisphere for episodic retrieval tasks. This model then proposes that semantic and episodic memory must be distinct because they have drawn in separate areas of the brain. So, a neuroscientific model called HERA. HERA means hemispheric encoding retrieval as asymmetry, attempts to account for different in hemispheric activation for semantic versus episodic memory. So, in the right side, here's a picture. As you can see, encoding. So, encoding proficiently associated with the LPC, PFC, prefrontal cortex activation. Retrieval proficiently associated with the RDL, PFC activation, report definition language activation. So next, memory and the brain. So according to Marsha K. Johnson, a memory is a mental experience that is taken to be a veridical, truthful presentation of an event from one's past. Attributions we make about the origin of the active information that constitutes our mental experience are the results of cognitive processes that encode, revive, and monitor information from various sources of experiences. The integration of information across individual experiences is necessary for all higher order context through. But this is very capacity for creative integration of information from multiple events makes us vulnerable to false memories because we sometimes misattribute the resources of the information that comes to mind. Source monitoring errors include many types of confusions. For example, attributing something that was imagined to perception, an intention to an action, something only heard about to something one witnessed. Source something read in a tabloid to a television news program or an incident that occurred in place A or at time A to place B or time B. Okay. Next. A taxonomy of the memory system in terms of decisions described in the previous section is shown in 5.8 below. Square, 1986 to 1993. It distinguishes declarative explicit memory from various kinds of non-declarative implicit memory. Non-declarative memory comprises procedural memory, priming effects, simple classical conditioning, habituation, sanitization, and perceptual after effects. In yet other view, there are 5 memory systems in all: episodic, semantic, perceptual, others connecting things in the base of their form and structure, procedural, and working memory by chapter 2000. So, figure 5.8, a taxonomy of the memory system based on extensive neuropsychological research, Larry Square, has posited that memory comprises 2 fundamental types: declarative explicit memory and various forms of non-declarative implicit memory, each of which may be associated with discrete cerebral structures and processes. So that's all.